Thank you. John kind of put me on the spot, John Detmers, to pull something together here, and I had an option to kind of steep this in some of the fishery data, and Dr. Ed Roseman's not here, who's doing a bunch of this stuff in addition with Mike Thomas and his crew with Michigan DNR. But what I'm going to focus on is the process, and I talked a little bit about this with this morning's talk, but essentially this is really going to be focused on the process of working through over a decade of habitat work that's going on in the scudders, the St. Clair Detroit River system. So we're kind of at a point with the number of folks that we've added to our working group, and it really, as much as I always say to people, and I tell my staff this all the time, we work with people, we don't work with agencies, but the list is pretty exhaustive anymore with the number of folks. I think for our Here and Erie Corridor Initiative, we're up to about 80 to 90 people that are participating, 30 agencies. So this is really kind of a cross-section of a lot of people's names that are identified with the various agencies. So thanks to all of them for helping put this together. So just to get you acclimated, connects the upper and lower Great Lakes. It's an open system. Historically had some of the most concentrated spawning habitat in the Great Lakes. And this is really kind of our model that we've followed to get much of this work done. And sort of the bullet 6 there, the adjustment, is really the feedback loop and the important part of this. And Scott, it was neat listening to what you said, that monitoring is a big part of this work that goes on, because these aren't cookie cutter type projects. And if we just move forward without having monitoring tied to this, I think we would be probably moving many times in the wrong direction. And I'll have an example of that at the end here. So I'm going to just kind of walk you through 1 through 5 with the process that we work. Assessing the problem, defining it, evaluating the current status, and then developing hypotheses to guide the action. And this is an old quote that Justin pulled and put in this presentation. Justin Scheidt helped me put this together. I find myself more and more depending on my staff to get me good pictures and good stuff to integrate into this thing as I'm moving further away from being a biologist and more of a person managing I guess herding cats, I guess is how I describe myself, dealing with personnel issues and things like that. So at any rate, St. Clair Detroit River System, huge runs of native fish here, largest commercial Great Lakes fishery in the 1800s, and that's kind of the outline there that we're talking about, we're working in. Today, it's the origin of much of Lake Erie's commercial catch, a $2 billion a year fishery, and that's kind of the so what question I get from the public. People that deal with fish, you know, we understand what numbers mean when we're talking about production, but from the standpoint of the public, when I can say, well, this is $2 billion that's at risk and at stake based on, you know, habitat work that we're doing here potentially. So 65 species of fish, 16 threatened or endangered. Largest remaining population of sturgeon in the Great Lakes is within this system. This is the habitat we lost. This is the lower Detroit River, Livingstone, Amherstburg Channel. This is a dewatered section of this, I think back in the 1800s. Limestone bedrock, a lot of interstitial space that was really valuable to many species of fish. And this is the construction phase when they were building the Livingstone Channel. So not unlike many other places in the Great Lakes. Historical changes to habitat. Detroit River, this is back 1870s through 1960s, created 60 miles of shipping channels, 30 million cubic yards of material removed, and 15.5 square miles of river bottom that was ultimately covered. So evaluating the current status, studies of historical and current spawning habitat. This is ongoing with a number of folks that are in this room, Ministry of Natural Resources, DFO, Fish and Wildlife, MDNR, and others. Fish community inventories, species-specific fish population monitoring, telemetry studies with work that we're taking advantage of that with the GLaDOS program, and physical habitat assessments, and something that we're really ramping up with the availability of new technologies coming online. So pre-restoration biological assessment of candidate restoration sites, and this is some of the USGS EGMAT data that Ed Roseman provided there. So just looking at the cross-section of the site. So developing hypotheses to guide the action, and essentially it comes down to lack of spawning habitat limits fish production. This work that we're doing is closely tied with delisting the AOCs of the Detroit and St. Clair rivers. So those are two of the big guiding documents. I've had the question asked to me, okay, why are you building sturgeon habitat? It's not just sturgeon habitat, it's other species as well, but in a system that has the most robust population in the Great Lakes. And that's, again, one of the drivers. This is one of the delisting requirements for the beneficial use impairment of loss of fish and wildlife habitats and loss of fish and wildlife populations. So second bullet, design and benefit recreational and commercially important fishes like walleye and whitefish, and recovery and sustain state of Michigan provincial T&E species like lake sturgeon and the northern mad tom, which I think we've seen a couple pictures of those here. This is a pretty important bullet, this consensus building and identifying your constituents. We're using this collective impact model and utilizing that in the way that we've developed the Huron Erie Corridor Initiative. That's the picture of the group on the bottom there. And again, as I talked about earlier, the two images on the left, the white documents there, these are the PAC documents for identifying the BUIs in the system. We really embrace this whole notion of outreach and engagement, and that's just not just the public. This is congressional folks are invited out every year. They've been on our boats with us. We're demonstrating to them how we are taking tax dollars, both in US and Canada, quite frankly, and really dovetailing these things to make their dollars go a long way. Essentially, not working in a silo. We're working with the state. They have expertise they bring. We're working with the ministry. They have expertise they bring, and so on with each of the respective agencies. So, and then putting this, much of this is Great Lakes Restoration funded, and demonstrating to the likes of our political folks is incredibly important and gets us a lot of traction with when we're trying to pitch these and new projects and getting letters of support and stuff like that. So integration into larger restoration and management plans. I think we talked about that with the lamps and some of the other things. The direction that we're going with our work is closely tied with, we've reviewed those, our science and monitoring group that is reviewing this and identifying our priorities within the corridor are based on these other documents being integrated into our particular working document. Science coordination team, again, here's a few list of some of the names that are involved. Rich, are you still in here? My apology, I didn't get you on the list here, but ministry's on the next slide. Here we go. So, I'd be remiss, and there's always a litany of folks that are involved, a lot of invested time and energy by many, many agencies to make this a reality. And again, this is, I think we're on 13 or 14 years. So, developing a restoration plan, the earlier projects were really based on a lot of fishery type folks, multiple rock types, cross-channel layout. And again, goes back to, I think, what Scott had mentioned about assessment being an important component to that. The more recent projects, from the things that we've learned along the way, again, following the feedback loops on the adaptive management wheel, or the model. Recent projects have incorporated the lessons learned. We use a single rock type, long, narrow design placed in high flow velocities of the river systems. This kind of goes in a couple of phases, prioritizing restoration locations, this GIS model, and then the Benyon-Manny model on the right-hand side there, identifying the high velocity areas. Additional considerations, proximity or existing spawning locations, known contamination, sediment transport, and things of that sort. Phase 2 of this, and again, this is some of the more contemporary things that we've been building into this work in identifying these priority areas. And Alistair was in here earlier. I'm not sure. Are you still in here, Alistair? Yeah, there you are. I think I'm answering some of your questions here, right? So water velocity, the ADC data, this again is much of USGS, their wheelhouse. We brought in hydrologists from the University of Michigan, from Denver, that are now participating in this work and identifying this. Bathymetry, sediment characteristics, side scan, underwater video, scuba diving, biological activity gets it back into the biology side where we're more comfortable. Fish and wildlife, ministry, Michigan, DNR, and others. So. The hydrodynamic modeling, USGS GeoLab in Denver has been responsible for, again, some more of that modeling work that's taken place. Some of the things that we had considered along the way, reef shape, Dr. Alford at University of Michigan has been running models to determine alternate potential shapes for construction of these reefs. Fourth part we get into is the implementation. Construction of the habitat, depending on the conditions of the river. The upper pin there in the St. Clair River is at Hart's Light. Higher velocities there, and they've gone to a dump barge as opposed to a GPS-guided clamshell bucket like we used in the Middle Channel and at Point Aux Chenes. It's quite a bit more precise with the clamshell. The dump barge is a lot faster, but it requires kind of post smoothing of the rock material once it's dumped out there. Reef Materials tested a number of things early on with some of the early experimental reefs. We used coal cinders, which mimicked what was already in the system. This is spent coal. Rounded fieldstone, which is more costly, and then mixtures of limestone and other types. The rounded fieldstone is similar to what's up at the Blue Water Bridge and naturally in the system. Invasive species consideration. This was a big one for us early on with this. We consulted and came to a compromise with the sea lamprey control folks. Ideally, we would have wanted to put smaller rock materials in there, but at the expense of potentially adding to the problem in the system that we're starting to deal with in Lake Erie, we've moved away and really chose some of the largest materials, 4 to 10-inch limestone. So round gobies, I think, are kind of every place anymore, and so I think that's just part of the reality here. So locally quarried, inspected, transported to site, these are all things that reduce costs when it's close. Construction oversight, again, this is some of the folks at JJR and the marine companies that Rich had solicited at the Fighting Island Reef. Competitive bidding, ongoing communication with contractors, final construction verification, and then continued monitoring, work that GS and some of the other folks have been involved with. So these are the 6 completed reefs. We're, like Scott said, these are in the millions of dollars range. These are not small projects. Grassy Island is the most recent one. Point Aux Chenes, Middle Channel, Hart's Light, and Fighting Island was augmented in 2013. But these are all in the size of 1 point so to 3 or 4 acres in size. Monitoring and evaluation, biological assessment. Again, we started early on with these projects and looked at them project by project and looked at the response right associated on those sites. Our science and monitoring group with the Huron Erie Corridor Initiative, the Scudders Initiative, I should say, we're working to develop system-wide indexes to look at this as a much larger, comprehensive production coming out of the system rather than very project-orientated. So more to come, John. I guess that's where ultimately we're going to be going with this, is to have that kind of data in the coming years. So just one quick shot, looking at using a before-after control assessment for all of these projects early on. This was Emily Buchart did this work, and looking at the larval sturgeon production coming out of the Fighting Island reefs, I think is where these were at, Rich. So general recommendations: match spatial and temporal extent of the biological responses and physical stressors, monitor the physical and biological changes, again, that monitoring component, use consistent methods over time, measure quantitative response, and that's from Matt McLean et al., some of the publications that have come out of this work. Physical assessment, and this was the example I wanted to show you and hopefully get through this quickly, but 2012 we put the reef in. Again, the advent of cheaper technologies with side scan sonar. This was initially done with USGS, about a $150,000 piece of gear, and as a consequence, limited amount of access to that to do this. But this was the no-miss design, cross-channel, and ultimately by 2013, the hardness index of that, essentially we had infilling that was taking place on there. So again, lessons learned in the process of doing this. If we did a cookie cutter approach, we'd be still heading down probably this path, and that doesn't take us in a good direction. So again, this adjustment feedback loop, those arrows that are connecting back to the rest of either assessment, consensus, restoration planning, implementation, it's essential that you have funding available to conduct a level of monitoring that will give you good information, good science to drive the direction we're going. So other adjustments: Belle Isle, we discontinued the use of anchor stones. Again, that was 04. Fighting Island, Middle Channel, we no longer use the mixed rock types. Cross-channel, no miss design, sighting in the highest flow velocities, Hart's Light Reef, Grassy Island, modified reef shape and location to accommodate navigation. We're getting pushback. Again, a new player to the table where the commercial, the commercial navigation group from the freighter industry, essentially, their concerns were if we put these too close to the shipping lane, that in fact the ships would be disturbing the material, and they didn't want to be responsible for the reefs being moved. So lessons learned, probably the big yellow bullet there, the building and facilitating a successful team. I can't stress that enough. I think all of us are kind of astute in that. That's what we do. That's what we do as part of the Great Lakes. We're all sort of in this group of folks as we come in to work on this with these facilitating organizations that are in place to help foster this. So for more information, I got like a minute and a half left here. So this is the document I was referring to earlier. I noticed they're gone, so I guess that's a good thing. But it's on a couple of websites. The Michigan Sea Grant, if you did Huron Erie Corridor Initiative or scutters.org, you'll be able to get a copy of this document there. So that's my last slide.